size of the image. Ray diagram I may not be able to give. This is the objective. This one. This is the moon somewhere here. The diameter of the moon. So what we know is the diameter of the moon. Its angular size of the image is asking. So it will subtend an angle alpha. How to calculate that? Oh, this I think I'll don't go for ray diagram. Don't stress on ray diagram. Just have a basic thing. What is that one? So this angle subtended by it. The final image will be formed. The final image formed. So that angular size of the image of the moon. That's what it's asking. And there's the length of the tube. Anyway, there's a far away, no? So what is the distance? So after refraction, the rays will form image I1 here, I2. Okay, that there is another thing. So F0 and this is Fe and I is here. So we know F0 and Fe. First what happened? Magnifying power of telescope. What is the magnifying power of F0 by Fe only? It is always in normal adjustment what we do. So we know F0 Fe will get M infinity. Then what is the length of the tube? F0 plus Fe. What is the basic definition? M infinity is what? Beta by alpha, no? It is alpha. Can we calculate? We know diameter and we know this distance. This will be very tricky questions, huh? Because some small basic idea you must have that one. So this small d I'll write it, because capital D we use for least distance. No? So what is the diameter of the moon given? (10 to the power of kilometer). And what is the distance? This is. Okay, with the help of this, what will happen? We'll get the alpha. Then beta is what he's asking. So F0 by Fe, and this will be alpha, what you can write, dm by x. You'll get that angle. Agree this one. So what is this angle? Degree or radian? What we should say? Radian, no? It is. So you convert that degree pi by 180. Where is the image, sir? The image, what happened? In fact, the I will see image, yes, I will see the image where that particular image, what happened, will subtend angle. So it is as good as like the rays are coming in, no? So you will see the angular size of the image of the moon. So what is this beta? Angle subtended by it. Nothing but shall say diameter of the moon. Actually, I should not show. So to make you, some of you understand, I'm just showing the image. Huh? This is the image of moon. So this angular size is not asking the diameter. Huh? Is asking this angular size. Angular size means you mean to say this one. Fine. Actually, it should have been M25. If it were M25, I would have given diameter also. If this were M25, then L25 it were this one. Then what happened? Where the image is formed at 25 centimeter, then you know beta, then you can get the diameter. But it didn't said anything, no? We should always work out for what? For normal adjustment only. if the funnel image formed at 25 centimeter, then you could have easily shown the diameter. It's not asking diameter, angular size of image of the moon, that beta is asking. If they say the final image is at 25 centimeter from the objective, then you can predict the diameter. Okay, if you want, I'll change this angular size of the image of the moon formed at near point. But nobody should ask that one. To make you understand, I'm changing the problem. What is the formula for M25? F naught 1 plus Fe by D. Am I right? Okay, there's a thing. So what is the L25 now? L25 will come F naught plus UE. This is distance UE, no? And this is that I1 we should not show it. And this is at 25 centimeter near point. So how to calculate UE? How to calculate UE? UE will be now the diameter of the moon, what happened? We are able to tell. This is DO, you call it. Diameter of the image. So beta we get from here. After getting beta, then what will happen? This beta you can write it as di by x. And what is di? Di by capital D. Okay, fine. So these are the ways here. You can see that appreciably, sir, what is the diameter of the moon? 10 to the power of 3 kilometers. So what do you expect in how many kilometers this diameter of the image of moon? Anybody? I just want your common sense here. Of course, sir, but we are not seeing telescope. If you have seen telescope, no, so what do we think normally? This will come in kilometer. So can you see an object which is at a diameter of 1 kilometer nearby your eye, and what is 25 centimeter? Just you try to see. I think you are sitting nearby wall or something, or the mobile phone only. Keep it at distance 25 centimeter, and its height of the mobile is 1 kilometer. Can you see it? Not possible, no. So what do you expect the DI? DI will be of order few centimeter. And what all things that are there in the moon, they are available. Object is a very big in size, far away, appears small. So the image of that is brought near to the eye, whose dimensions will be of order few centimeters. That is enough. We can see things clearly. Getting the trick, there's a thing. I think you, whatever you do, no. I think in YouTube, what happen? You can just check, like the videos they show. Nowadays, what happen? We have a like a telescopes where you can connect to laptop, and whatever you see, no, it can. I think even the Apple iPhone will come with a telescope options, that one. So you can fix one lens, and what happen, you can see the mobile will become a telescope. Already one lens is there, another lens you have to fit up. And now you can use that Apple iPhone as a what, like a telescope. And you can even take videos, you can capture videos. So such videos are there in YouTube, huh? Just see once. The moon weapon will appear some sort of 5 or 10 centimeter. Very clearly you can see things. Got this one? These are the typical problems what you can expect in exam. Okay, I think such things are not there in our icon book.